So at this point you should have just watched the video about what L'Hopital's rule is and where it comes from. Now we're going to just do some examples with it. Alright, so these are examples with L'Hopital's. Let me check it. Examples with L'Hopital's. Okay. Should probably do this in pencil considering I had to write that twice. Okay, so let me look at some of my examples here from years past. Okay. Okay, so here we go. First one. Directions for these are just going to be to evaluate each limit. Okay. So here we go, right? So we have this, okay? So the first step in doing this is knowing that L'Hopital's actually applies, okay? So you can't just say, oh, I'm going to take the derivative each time. So first is you do a plug-in, right? Plug in C to try to evaluate the limit. Okay. So if I plug it in, the top there's going to be 1 minus, oh, cosine of 0 is 1. So 1 minus 1, that's 0, and the bottom 0, right? So therefore, and these 3 dots mean therefore L'Hopital's applies. Before you use L'Hopital's, you must prove that it applies. You can't just start taking derivatives. If you don't have that, you will not get full credit when we have, if and when we have our assessment on this, right? So, okay, so L'Hopital's applies, so let's go ahead and take the derivative. So the derivative of cosine is negative sign, and it's already negative, so it becomes positive. Derivative of x is 1. Okay, now at this point, right, so step 2, take derivative of top and derivative of the bottom. Okay. Now, big question people have to say, wait, why didn't you use the quotient rule? Because I'm not looking at it as a whole thing. I'm just looking at the top function and the bottom function, and I'm individually doing these. Remember, when we did limits, right, we didn't have derivative rules, right? There's not we don't need all those derivative rules as we're doing it. We're just looking at the top over the bottom, right? So limits were very flexible for us in doing this. Okay. Now let's and so I take the derivative top and the bottom. Step 3, right? Evaluate the limit. Okay. If you get 0 over 0 or infinity over infinity, do L'Hopital's again. Okay. So you can do it over and over again, right, for yourself if you need to. Okay. You may not need to. In this one, we plug it in. Sine of 0 is 0. The denominator is always 1 because it's just that number. So there's our answer. Our limit there was 0. Okay. To do this one before we did it with a graph, or we may have you would have to use a Pythagorean identity like from trig. Like it just telling you, this is going to simplify things, right? This is a good thing, right, for you. This is really going to make this so much easier for yourself. Okay. Next example, let's look at this. So let's say we have the limit as x approaches 0 from the right. Now, this from the right might not matter at all for the problem. We'll see. Okay, I'm just putting it there, right, for myself, just to show you can use directional limits. Okay, so we get this. Okay, so let's get started with this one. Let's think about step 1, right? Let's evaluate the limit, see if it gives, see what happens. All right, I got top is 0, bottom is 0 minus 0, 0, 0. Therefore, L'Hopital's applies. Okay, so we have to do that every single time. Next thing, okay, L'Hopital's applies. Let's use it. So take the derivative of the top. Okay, you must write this limit here. Okay, derivative of the top. It's cosine of x minus 1. Okay. Now let's plug it in. Plug it in. We get 0 on top. We get 1 minus 1. We get 0 on the bottom. Okay, so, right, L'Hopital's applies again. I'm not going to write. I'm just going to say, hey, look, right, L'Hopital's applies. So let's go and take the derivative again. So it becomes 2. Cosine is negative sine of x. Derivative of 1 is 0. I go ahead and plug in this. So I get negative 2 over 0. Okay, so I got 2 over 0. What does that tell me? Okay, now this is not L'Hopital's, right? Because there's a number on top, 0 on the bottom. So you may or may not remember that this is going to be an asymptote. If we think about the graph of it, that just meant this goes way up to infinity or way down to negative infinity. And the easiest way to figure that out, right, is to think about what happens. If we're approaching 0 from the right, that means, right, 0 from the right, that means we're in the first quadrant angles, right? Our angles are in the first quadrant, right, which means sine is positive, but it's a negative in front, so it's a negative, and it's getting really close to 0, so we'll say small. Remember that strategy we did? So it gives us negative infinity. Okay, so there's our limit there. All right, negative infinity. So we do have to remember some of our limit rules from before as we do these. Okay, keeping in mind that if you have a number in the top and a 0 in the denominator, that means it's going to be positive infinity, negative infinity, or does not exist. And you just think about what's happening as you approach from that direction. So this one was important that we had directional limit. We needed it because if we didn't have the directional, we'd have to do both sides and see if they match up. Okay, going back to September, October stuff. Okay, so let's try another example. Now for this next one, I'm going to do out these examples from here on out. I would pause the video after I write the problem. You try to solve it and then watch my explanation, okay? So let's try this one. 4x squared minus 5x over 1 minus 3x squared. Hit the pause button on this, right? And then see what you get, and then check your work against mine, okay? So now that you've hit the pause button, you've tried it on your own, right? If you haven't tried it on your own, right, you should have already done that. So hit the pause and try it. Okay. So now that you've tried it on your own, if I plug this in, I get 0 on top. I get 1 on the bottom. Hey, I got 0 over 1. Okay, right? Does L'Hopital's apply? No, it's just 0. Boom, done. Game over. Right? Problem's done. Okay. No L'Hopital's there. Why no L'Hopital's? Because it wasn't 0 over 0, right? This is one you totally could have evaluated before. If I'm looking at the next one here, let's try this. Okay. This is e to the x. So if you don't want to hit the pause button on this one, that's okay, right? No big deal. You can just watch me do it. But if you want to try on your own, go ahead. Okay. So I plug in. That's e to the infinity and infinity squared, and that's just going to be infinity over infinity, okay? So this is the other case where L'Hopital's applies, when it's infinity over infinity. Okay. You do need to write this out every time L'Hopital's applies, right? So no being lazy on those. Okay, so now I take my derivative. Derivative of e to the x is itself. The derivative of the denominator is 2x. I plug this in. I get e to the infinity. I get the bottom as infinity. So again, L'Hopital's applies. Here you can be lazy. You can just put that arrow to it. All right, take the derivative again. And this gives me e to the infinity over 2. E to the infinity is infinity, right? So it's infinity over 2, so it's going to be approaching infinity. Okay? So it's okay that your answer doesn't come out to something nice at the end, right? That can happen, right? No big deal. Okay? I'm going to continue to run through some examples. You watch as many examples as you need, right? And